but it may be one or the other. Put this under irrational numbers. Under irrational numbers. We're going to go all textbook on you here. Okay, I'm going to talk about that. And I guess the book tries to help you out, and I suppose this is probably a novel idea. Let's start with a number line here, by the way. Let's start at 0, shall we? What should we go up to? Nope. Ain't gonna have time for that. We probably should have gone up to 10. Let's just go up to 7. Remember when we discussed there, we have the perfect squares. Okay. But we then have numbers that are not perfect squares. Let's jot some of them bad boys down. Let's do this. Let's just put a whole bunch of square roots down. Square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, square root of 10. And if you're looking at a number line and where those bad boys would fall, here is probably the first thing to think about. Some of these are perfect squares, are they not? That's your point to say yes, yes they are.
Yes.
2 yeses, please.
Yes. Yes.
With a pause in between. Yes, yes they are.
Yes. Yes, they are.
All right, the square root of 1 is what? 1. So right here at 1, you would put, that is in fact the square root of 1, is it not? Yes. Yes, it is. The next perfect square we have in our list of numbers there is the square root of, which one works out evenly there? 4, which is this one, which is what? 2, is it not?
Yes. Yes, it is.
Let's try that again. 2, is it not?
Yes. Yes, it is.
All right, so the square root of 4 is 2, which goes right here. Now, if we know that, ladies and gentlemen, based on your 7th grade comprehension here, maybe we should blow this up to make this much, much, much more exciting. Thank you, somebody said that. Go that again. Who's out there? Somebody. Work with whoever it was. That Soph, was that you?
Yeah.
Thank you for that. Notice between the square root of 1 and the square root of 4, we have the square root of 2 and the square root of 3, which are what we call irrational. Why? Because there's really no good answer to them. They're decimals that go on forever. As a matter of fact, well, let's do this first. But because the square root of 1 and the square root of 4 are perfect squares, you know that these two have to fall somewhere in between there, so we can jot those down. You know, you can just kind of do it here. The square root of 2 and the square root of 3 both have to fall between the square root of 1 and the square root of 4. So that means the square root of 2 and the square root of 3 have to be between 1 and 2 as numbers. Yes?
Yes.
Now,
Yes.
just for fun, I know this will confuse and amaze your friends. We're going to grab a quick calculator here if it pops up. There you go, Mr. Calculator. What do you suppose the square root of 2 is to the best of our knowledge? Somebody taking a wild guess. That's what everybody says, but it's not. 1.414. So we're going to jot that down just so you have that as a reference. The square root of 2, and by the way, here's our approximately symbol. You do this little squiggly equal sign, is 1.414. And it goes on forever, but we're just kind of round it to that. Which means the square root of 2 falls where in our number line? Here's 1.5. Let's make that half. So 1.414 is probably about right here. The square root of 3, you're very, 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 very much wondering is, somebody have a guess on that? No.
1.7.
There's some guessing out there. I love that. Let's do it. Square root of 3 is 1.732. Which means, if this is 1.5, what would this line halfway between there be? 1.75. So 1.732 falls right about here. If somebody gives you the square root of $3, they have given you about $1.73, which may or may not make you feel good or bad or otherwise. Continuing on with our handy-dandy little line here, we've got the square root of 5, the square root of 6, the square root of 7, the square root of 8, the square root of 9, all that sort of stuff here. What's the next one that I know for sure? What's my next perfect square in my list up there? Olivia? The square root of 6 is what?
3.
It is not 3. Anybody? 3 times 3 is not 6. Every time I've done 3 times 2 is 6, and we got to get out of that whole thing here. Zachary? Oh boy. Anybody? Next perfect square in that list of numbers, square roots I gave you there is Grace?
8.
What? Square root of 8 is what? Did you say 4? No, that's 8 divided by 2. 4 times 4 is 16. Wow. Closing?
9.
The square root of 9 is
3.
3. So right here, you know, children, I'll do it in blue. Right here at 3 is the square root of 9. Which means what has to fall between 4 and 9? The square root of 5, the square root of 6, the square root of 7, the square root of 8. All have to fall in this little patch right here. We're not going to write them all down, but you know, you just know they have to fall there. My next one, my next perfect square is, let's just do this here. What's 4 times 4?
16.
So my next perfect square is the square root of 16. So guess what has to fall between 9 and 16? The square root of 10, the square root of 11, the square root of 12, the square root of 13, the square root of 14, the square root of 15. And so on and such that, and hitherto, and forward on, and forward progress, and backwards, and all that sort of gadget there. You should, children, at your 7th grade level here, if I told you, if I gave you the square root of 63, you should be able to give me at least a decent approximation to that, or at least what numbers it has to fall between. How about that? The square root of 3 has to fall between what, and is probably closest to what number? Wow, here we go. This is going to cause you great trouble. Square root of 63 would be about what number? If I gave you the square root of $63, about how much money would I have to shell out of my poor empty wallet? And I mean that sincerely from the bottom of my heart. Zachary?
Around 8.
Why do you say 8, sir?
I think I think it's 64.
Right. It has to, you know it has to fall between 7 and 8. Because 8, 7 is, times 7 is 49, 8 times 8 is 64. 64 is too high, 7 is too low. And 63 is awful close to 64, so it's going to obviously fall closer to $8 than it is $7. What about the square root of, I don't know, 32? If I asked you the square root of 32, it would be close to what, would you say, mind you? Think about what numbers, when they multiply together, give you close to 32. Above and below, and figure out what it's closer or farther from. John?
Between 5 and 6.
Okay, between 5 and 6. Why? Because 5 times 5 is 25, and 6 times 6 is 36. Which one do you suppose that it's probably closer to?
6.
Probably 6. It's 4 away from 36, and it's what? 7 away from that, so it's probably closer to 6. Got that? Anybody have anything they want to add? Now, since not, we also have to think about this in terms of squares. If I gave you a square, and I said that each side of the square was 8, what is its area? To which you would say, well, sir, 8 times 8 is,
64.
jump in there, 64. Well, this is the same number times itself, is it not? Which means this. If instead of giving you the sides of the square, I gave you its area, here's my square, and I said its area equals 64, could you tell me how long the sides is or are? Emma, it's what? What is, how long are each sides?
8.
8. Because 8 is the, what am I looking at here? To find each side, you take the square root of 64. Because that is what number times itself gives you 64. In this case, it happens to work out nicely, and each one is 8, which is what I started up with there. Which hopefully you can make the deductive leap to this, children. If I said a square had an area of 6, and I asked you how long are each of the sides, anybody? Now, here we go. I need you to take 3 deep breaths. On the count of 3, 1, 2, 3. Look for the pattern here. Back up to this one. The area of this I said was 64, and each side was the square root of 64. If the area is 6, each side would have to be, I love the excitement there. Emma Miller?
I forgot it now.
I'm going to say that again. Work with me here. I said the area of this square was 64, which meant each side was the square root of 64. 64 square root of 64. If the area was not 64 but 6, each side would be, find the pattern, find the connection here. Emily, got a thought? Maybe one more will be in the process here. Let's say my square is, area is 100. Which would mean what number times what number is 100, which means each side would have to be the square root of 100. Which in this case works out nicely, it is 10, is it not? 10 times 10, 100? Now notice, on this one, the area was 100 and each side was the square root of 100. Notice on this one, the area was 64 and each side was the square root of 64. If my square was 6, Brian, each side would have to be the,
Square root of 6.
wow, I think we've had an epiphany. Now, the unfortunate thing, children, is unlike these 2, 3, the square root of 6 is, what type of number? Irrational. It doesn't work out. You can kind of come up with a close to, but you won't get an exact number. Joseph, the square root of 6 is close to what? Or give me between. Kind of like. Such. Yeah, between 2 and 3 somewhere. Probably closer to 2, a little bit closer to 2. Do you get that? Is that kind of, let me give you another example. What if my square, the area of my square was 3 inches squared. How long would each side of my square be? Or close to, or something like. Sure. Which is the square root of 3.
Yeah, square root of 3.
Which we said was close to 1 point what?
732.
Was it 732?
Yeah.
An epiphany again. Let's try one more. What if my square was 20 inches squared? How long would each side be? How about raise your hand if you have no idea? Let's go the other way around. You have no idea what the side would be? Well, let's go back to this one and see if we can make the connection. Here my area was 100, so each side was the square root of 100. Here my area was 64, so each side was the square root of 64. Here my area was 6, so each side was 6. Here my area was 3, so each side was the square root of 3. So here if my area is 20, each side would have to be.
Square root of 20.
That's it, ladies and gentlemen. That is it. And again, the square root of 20 doesn't work out evenly. So, I mean, you could guess it's got to be between what, though?
4 and 5.
Between 4 and 5, somewhere along the line. One more, because I think we are very close. What if my area of this was 1,635? How long would each side be? Whoa, how did you get that answer so fast? Irrationally speaking. Joseph, do you have an answer for me by chance? You have no idea? All right, let's go back. See if we can find some sort of a pattern, Joseph. Joseph, the area of my square here was what? What? No, that's my, which is the, what is this thing here? Square root of 100, right? Area of this one was 64. Each side was, area of this one was, each side was, area of this one was, each side was, huh? Area of this one was, each side was, here we go. Area of this one is, each side has to be, I think we've got it.
Ooh.
Shake it up, baby, now. Shake it up, baby.
Maybe I'm smile. Do you think we have the pricing on the odds?
See, it's when band is
Yeah, those band people bring us down. That's what I'm saying.
And the sick people.
Well, you better stop speaking of the devil.
Speaking of
All right, this is your assignment. Write this down. Take a little note. Take a look. See here, kids. Band people, listen to you. You can do all of this. Because we said that these are approximations, you are going to do me a favor and find out just how exactly close they are. Which means this. Your assignment for tomorrow is to take both of these numbers and square them and see how close your answer is to both 2 and 3. In other words, you're going to take 1.414 and multiply it by 4 on 4, see what you get for an answer. And you take 1.732, multiply it by 1.732, and see what you get for an answer. Hint, should be awful close to this, but I want to know how close it is. We have 2 multiplication problems. We have 2.5 minutes right now to do it. And then you can thank your